So today I have the pleasure of interviewing Dr. Mark Micire, ex-CEO of Search and Rescue Robotics startup, ex-program manager at DARPA, ex-Robotics Group Lead at NASA AMES, and ex-technical search specialist at FEMA, which is the Federal Emergency Management Agency, and now head of robotics at Woodside Energy, or as we like to call you, just Mark. So I thought I'd kick us off with a bit of an icebreaker. I might be able to guess some of these, but I thought if you could tell us your favorite food, your favorite hobby, and your favorite movie.
All right, let's see. Favorite food, probably hamburger, cheeseburger specifically.
Yep.
As basic as that is,
Yep.
that's definitely a go-to for me. Favorite hobby, pretty hardcore into just computer nerding and geekery and stuff like that. A close second would be automobiles.
Okay.
I've spent some time owning and driving some really fast cars, so that would be my other one.
So I'm 0 for 3 right now.
What was the last?
And your favorite movie?
Oh, War Games.
War Games?
Far. Yeah, that movie set the course. That was the trajectory-setting movie of my life.
Of your life? Yeah, awesome.
Not that I almost started a nuclear war, but the computer part for sure.
Yeah, okay. So 0 for 3. I had you as a burrito.
Okay.
Photography, and I took a wild guess at Space Odyssey X for the movie. So you've had a very interesting career as my introduction. Now I probably know a lot about you already, but there's still probably a lot I don't know. But I thought we could take a bit of a trip down memory lane.
Yeah, go for it.
Would you be able to tell us about the study you did straight after high school and what sort of led you to choose that study that you did?
So out of high school, I was very, very much into what we now call cyber. We didn't really call it cyber back then. It was security was the thing that the IT guys did when they weren't fixing servers. It wasn't really a career path. It was just this thing that sometimes
you think you did, yeah.
Yeah, and to put it in time and to make me feel old, you're talking mid to late 90s.
Yep.
So cybersecurity was not a career path. But it was absolutely where I found joy was breaking things, but specifically breaking computers and figuring out the way that things would fail, and then finding ways to do interesting things with those failures. So when I went to university through all of my undergraduate, although I was in a school of engineering, I was in computer science, and a lot of their stuff focused on a lot of the computer science core curriculum, but they actually had a bit of an IT bent to what they were doing. And I was also working a full-time job. I'll say on the side, it was more or less I was doing university and had a full-time job doing IT stuff. And then I basically burned out on it. Yeah. They say that the best way to ruin a hobby is to make it your job.
Yeah.
And so by the time I hit my senior year at university, I didn't want to do anything related to security, computer science, anything like that. Computer science maybe, but I definitely had the opportunity. I needed one elective course in my senior year, and there was this robotics course, and I grew up playing with radio-controlled cars and other things like that.
Yeah, awesome.
And I think I naively thought to myself, well, robots are nothing but radio-controlled cars with computers on them.
That's what I was thinking.
So this should be easy. Like I should be able to go in, and long story short, I ended up taking the robotics class, fell in love with it, and completely abandoned the cybersecurity stuff with the promise to myself that I would go back 3 or 4 years later and see if that had healed. And so, fast forward to today, that's pretty much, while robotics is my day job, on any given Saturday, just diving into and totally geeking out on doing cybersecurity and other type computer sciencey kind of stuff.
And you've given talks and stuff on operational security and OT. Yeah. So, awesome. So I found your dissertation title.
I'm sorry.
and for your master's study, and it's probably one of the more interesting sounding ones I've heard. Definitely much more interesting than mine. It's the analysis of robot-assisted search and rescue response to the World Trade Center disaster. Yeah. Straight after that, you then went into a robotics startup for 5 years. Would you be able to talk about what you did for your master's and how that sort of led to the robotics startup?
Yeah. So for the master's, I got very fortunate in that when the Trade Center disaster happened, the lab that I happened to be working in, so that's actually a good segue. So took that robotics course, started working in the lab that for the professor that was teaching that elective course, and basically Ended up being kind of the lab manager there. So I was fixing all the robots as a master's student, keeping all the stuff running for the PhD students. And then, and we had, part of the focus of the research at the lab was in search and rescue. And we really didn't know what we were doing at that point in the game. But there was some interest from the local fire department, and we thought it was a domain that we might be able to play into, just because putting robots in some of these like crazy hazardous situations just makes sense. And so myself and another grad student had started working with the local fire department and started getting some certifications. So we had done we'd done trench rescue and a little bit of hazmat and other things like that. And then September 11th happens. Our DARPA program manager, who was funding most of the work that we did in our lab, called us up and basically said, look, all of the equipment you have, and if you've got any personnel that can support that equipment, I need you to load it up and get to New York. Like, this is an all call.
Wow.
And so we were one of probably a half dozen different groups that were there. Now, strangely enough, and it was almost, I don't want to say it was by accident, but we certainly didn't plan for this. When it came time to actually go and deploy these robots, it was pretty much myself and my other student colleague, and then a couple of other folks that were with one of the other teams that had any training whatsoever, even in safety, as to how to operate on these kind of sites and stuff like that. And so very quickly, we kind of got pulled forward. And then the gift that I then had, but didn't realize it at the time, was I got to spend effectively the next, we were there for a total of 11 days. And during those 11 days, I was one of the operators of the equipment that we used on the pile. So that then became the thesis. So the theme for that thesis is we broke everything that we took up there. There wasn't a single piece of equipment that didn't end up busted in some way.
Yeah.
Each one of those breakages shows either a lack of engineering or imagination, or just the equipment wasn't prepared for what we were putting in.
You didn't know what you were expected to use it on potentially. Yeah.
Exactly.
Yeah.
And we were borrowing from other industries. So like the equipment, the most useful piece of equipment that we had at the Trade Center was actually a robot that was designed for pipe crawling. It was designed for like industrial inspection applications, that then we're now throwing into a rubble pile with dirt and mud and bodily fluids and other things. And so simple things like how do you decontaminate this robot wasn't something that was in the original spec for especially when you're dealing with biologics and other things like that. And so yeah, so we did. I had that experience, and then the master's thesis became an analysis of all of the things that we broke, with the idea that would become, these are all things that we would need to improve upon if you were to ever succeed in this fire rescue domain. Got done with my thesis and then realized there was actually a business opportunity there. And so
led to the startup.
So graduated, was fortunate to have a couple of really wonderful angel investors that were very supportive of me wanting to go forward and do this. They helped bootstrap the company. We spent about a year and a half developing the product. We actually did that as a partnership with the company that built the equipment that we used in New York. And in terms of manufacturing capabilities and other things like that, they just helped speed up everything that we were doing because they were already building equipment and had tooling and everything else. And then about 2 years later, we had a piece of equipment that was ready to sell. And we immediately sold I think our first units out the door, there was about a half dozen of them that went out to various groups, not the least of which was my former university.
And it's just the same thing that you brought in to demo to us?
The one that I brought in here, that is the same generation as the one that we used at the Trade Center. Right. Now, strangely enough, we actually do, so we actually just got a couple of the original 6 that my company sold back in 2004. Here, with the idea of repurposing those for doing inspection for Woodside.
That's awesome.
And so it's pretty cool. And those are actually, those pieces of equipment, because my company, we ended up not succeeding in penetrating that market and ended up closing it down. We literally that equipment's not built anymore, and so it was really kind of a cool opportunity to grab something that I know is capable. And then we might be able to use here.
Repurpose it.
Yeah.
What would you say the biggest things you learned from the startup experience? You're there for 5 years, and then looking back at it, was there anything you would change, or anything you would have done differently?
I think, so especially coming fresh out of university, I think the priorities that we had were wrong. We actually thought it was more about the product and having a finished product that was ready to go. I now, frankly, with all of today it is so common for us to speak about MVPs and just getting it out in front of the customer and testing that with the customer and pulling forward as fast as you can. And allowing an incomplete product to go to market with the idea that that informs what you might do for your complete product. Yeah. We were very, very naive in that regard.
You tried to get a fully functional product, yeah.
And I joke that in terms of the successes that we have, it's half joke, half like legit. I could probably recreate now in about 6 months what it took us 3 years to do before. And that's just because the idea that you're MVPing as fast as you can. And the other thing I don't think I really appreciated was the cost of humans. So the most expensive part of any, especially startup, is going to be the bright minds and the great people that you inspire. But you got to remember that as, like in my case as a CEO, every single one of their paychecks, like their livelihood rests on your ability to succeed in creating whatever this thing is you're doing. I definitely went into a startup not appreciating the weight of that on me. But then also just the ultimately what that comes down to cash flow, and that ultimately comes down to either sales or investment. Yeah. And so I think the group of, there were 3 of us that were kind of at the core of the start of the company. We naively thought that building the product was the most important part of any startup. And it is important, but it is not the most important. The most important, I would actually argue at this point, is making sure that you've got cash flow and enough runway to get yourself to the point where you can build the product.
Yeah.
So, yeah.
So it's not about the product; it's all about smoke and mirrors and no.
It's I would say it's more about communicating a vision and making sure that you're chasing the right vision, because
with your customer base or your stakeholders.
Exactly, because if at the end of the day you build the most wonderful freaking product on the planet
and no one wants it,
then you're not cash flowing, which means you're going to be looking for another job pretty quickly.
So the startup comes to an end. Talk to me. What's going through your mind when you were trying to decide what you wanted to do next? And then what? I know what you did, but would you then be able to sort of elaborate on what you then chose to do and move on to?
Yeah. So the funny part there was, I had helped get all of my employees jobs elsewhere. We knew we were running out of cash.
Yeah.
The next step that I did was I basically went to go get my PhD, and that was not planned. So I was actually liquidating all of the equipment that we had in our office. Everybody's gone, so everybody is off starting new jobs and everything else. I'm literally there in the office, tears streaming down my cheeks with, sitting in the puddle of my failed company. And I called up just a professor that I knew who had used our equipment in the past, and I said, hey, I'll make you a hell of a deal today. We've got this cool little crawler that I know you've used, and the legacy in terms of where it came from. I'll give it to you for, and I think it was like, I'll give it to you for 50% what our normal list price would be. And she says, well, I need to go talk to the department chair. She says, that'll come out of my overhead budget, and I need to make sure that equipment costs, I can do that or whatever. I'll call you back tomorrow. And I was like, okay. And I didn't think another thing of it, and then probably sniffled a little and, went home and cried some more. And so came back the next day, and she said, okay. She says, we'll take the robot. She says, but I'm going to want the ultimate warranty. And I kind of looked at the phone, and I'm like, what do you mean the ultimate warranty? And she says, well, I talked to the department chair, and this is November. So she's like, why don't you come up? You can work in my lab. I'll hire you on as a research assistant. And with that research assistant position, you'll basically get a tuition waiver to go do your PhD.
Ooh.
Right.
Yeah.
And so I quite literally just looked around the office and was like, well, I had nothing else going on.
Yeah.
And I really did kind of jump into that opportunity with no real clear understanding of whether I would actually finish my PhD. It quite literally was, I need to get out of this town. I need to get away from these robots. It was another kind of burnout kind of experience for me. And so the idea that I would go to Massachusetts, a place I'd literally never been before, and work on whatever research was that I wanted to do under the auspices of the university. That actually sounded like a pretty good plan at that point. And so I wish it was more deliberate than that. I wish I could say that it was like, well, the company failed, and then I had a very clear picture as to what I wanted to contribute to the society in terms of, technology through the course of a PhD, but that wasn't it at all. I just needed to get out of town, and this wonderful professor came in and said, "Hey, why don't you come up and work in my lab?"
Maybe it was good karma for taking care of the rest of your team first. And then you held, after the PhD, you had some sort of research positions. I know you did like an internship at NASA, and you joined FEMA over that time. And that sort of led up to, in 2013, you joined DARPA, which is Defense Advanced Research Project Agency for Department of Defense. And that was more in a project manager role. So I suppose you'd sort of transitioned back out of research back into sort of a manager role. What made you decide that you wanted to go, step away from the research for a bit and go into sort of that project management space?
So, being a program manager at DARPA, first of all, it's just honestly, it's such a privilege even to get the interview.
And we might even it might be worth, because I suppose like DARPA is extremely well known like in the US, but potentially not many Australians might not. So you feel free to give a little 101 of what DARPA does.
So the very brief version on DARPA. So its mission is to basically prevent and create strategic surprise. It was founded after Sputnik. So when the Russians launched Sputnik, the U.S., especially the U.S. intelligence and engineering community was very surprised by the Russians' ability to leapfrog ahead of the U.S. in terms of satellite technology. So DARPA was created to make sure that the U.S. was never in that position again. And so DARPA's part of DARPA's charter is to be disruptive, to question assumptions, and to play forward in a very kind of almost aggressive way with regards to its use of technology and other things like that. But earlier in the story, I'd mentioned that the person who called us to go up to the Trade Center was our DARPA program manager. I remember very early on just being enamored by what appeared to be just like these godlike positions in which people got to come up with very broad, sweeping ideas and then have millions of government dollars and to go execute on those ideas. And so that was, and that a lot of that was said in naivete. I actually didn't realize how hard it was as a DARPA program manager to succeed. But to put a cap on the 101, so basically DARPA is jokingly referred to as the mad scientists of the Pentagon.
Yeah.
So all of the stuff that the normal defenses would not come up with themselves, that's what DARPA is supposed to be thinking about.
It's like the very bleeding edge.
Yep.
Yeah.
And there's also a little bit of, and making sure that we understand what our adversaries are doing also. So you may be presented with we don't understand what this is, or what physics could they be leveraging to allow them to do the following thing that we observed. And DARPA ends up being kind of a consultant to the rest of the Department of Defense a lot of times in those regards.
And so what exactly was your involvement within DARPA? And what did you, I suppose, love about working at DARPA the most? And then if you're allowed to talk about it, potentially any of the most exciting projects that were under your program.
So, wait, what was it? Give me the first part again.
What your involvement was?
So the involvement, I mean, I came in as a program manager. Usually when you come in, you're coming in with some specific skill or some specific domain that they're looking for. I was coming in, strangely enough, with ground robotics experience, and I think that was where they were wanting to put most of my efforts initially. And then there was a big push regarding drones. So I was there kind of on the ground floor of drones really, and quadcopters and hexcopters really coming into their maturity. And so very quickly I was kind of repositioned into working a lot of UAV and drone type programs.
That's awesome.
Which was cool. It was way outside of my comfort zone.
Big drones we're talking, or
all the sizes. So everything from tiny little, like ones that are so small, smaller than commercial drones that we could buy today.
Yeah.
Like, all the way up to like Predator and Global Hawk class, like proper aircraft. So that was pretty exciting. And I had not especially worked in the larger aircraft domains before. And frankly, aside from working for NASA, I realize aeronautics is in NASA's name, but I had not been formally trained in a lot of the aeronautics side of things or whatever. And so that's, if there's anything you can say about DARPA, is it'll definitely push you way outside of your comfort zones, not only in terms of your ability to think big and to dramatically change things, but then to sometimes work outside of domains that you even feel competent in. And so so we, in terms of interesting programs that we ended up working, I mean, I'll say the one that was really inspiring was this program called FLA, is Fast Lightweight Autonomy, and that was basically quadcopters or drones, basically maneuvering indoors and in outdoor wooded type situations at ridiculous speeds.
What kind of speeds?
So north of 20 meters per second.
Yeah.
And where the whole idea with 20 meters per second is, with these things moving through the world that quickly, by the time you hear it or even have an opportunity for like it to catch it out of the corner of your eye, by the time you've turned and looked to see where the aircraft is, it's already gone and around the next corner. And so there was an element kind of stealth and just of very hyper agility in terms of its ability to move through the environment. We had at that point, there was some really great work coming out of the universities like the MIT and Stanford and University of Pennsylvania UPenn rather, that were really demonstrating agile and fast-moving aircraft. And so we wanted to just push that as fast as we could and see where it would go. So that program ended after I had already departed DARPA. So you're only allowed to stay at DARPA usually about 4 years.
4 years, yeah.
And most program managers leave around year 3. That's kind of where your street value kind of maximizes.
Yeah. And you're there for 5, were you? Or?
I was there for 3 and some change.
3 and some change.
And so long story short, it's my understanding that they achieved a lot of those original goals that we had in FLA. And
awesome.
Let's just say that I haven't looked recently, but about every time I check back, YouTube's got some other really cool video of some drone doing something stupid fast.
Yeah.
And a lot of those videos actually came out of the DARPA program that I started.
Yeah, that's
so
awesome.
That's pretty rewarding.
The DARPA Robotics Challenge that was going on whilst you were there was focused on disaster response robotics around 2013, 2016. Was that a coincidence, or did you play a part in that?
So
with your history in search and rescue and robotics
So I was there. So no, I actually won't take credit for any of that. I did help a lot. So the DARPA Robotics Challenge, there was a program manager that was the primary one that was he was the one that was the center of the DRC. I actually, though not surprisingly, helped a lot so at the very least, my role was running the expo. So while most of the videos and everything else is of the robots that are actually inside of the stadium doing their thing, there was an entire exposition that was there at the LA. It was a LA kind of civic center area or whatever, and so we had this huge area that was outside. And so I was kind of his. It was never officially this, but I was kind of his deputy. Program manager, yeah. And so while he was doing all of the important robotics work that was inside, I was kind of running everything else that was out in the. We kind of joked everything that was out in the parking lot, which it was a really big parking lot. But all of the exposition stuff or whatever, that was mine. What's interesting though to me is that a lot of the successes and a lot of the real advancements that we saw in the DRC, not to my surprise, were captured or were created by a lot of the same organizations and universities and other things that I'd been working with in the urban search and rescue world for many, many years prior. So seeing, especially for the Boston Dynamics Atlas platform, which that was really its first, although people knew about it, that was its first real premiere, now the public's seeing it really doing something. Yeah. And then all of the rest of the CMUs and the Stanfords of the world getting out there and doing their thing. That was pretty rewarding.
Were you, I suppose, surprised at most of the robots were all humanoid? what do you think the reason for that was? I mean, like, we're seeing a lot more emphasis on like legged robotics and stuff these days, but in that DARPA challenge, most of the contestants were all humanoid robots. What did you think
It wasn't mandated, but there was a strong, I will say that especially that program manager was kind of leading or biasing the field a little bit in terms of the work and the themes that they were trying to explore. The general theme for that one was, we have lots of areas and lots of facilities that are designed for humans. So, that valve or that gauge to read, or the ability to pull the hose or do the whatever that activity is, it's probably designed for a human to do it.
It's the same problem we have at the moment on Woodside facilities, doing robotics on Woodside facilities.
Exactly.
Yeah.
So the idea that you have a facility, whether that be a ship or a building that's collapsed or whatever, most of the apparatus that is there to work with that or to help remedy that situation is probably designed for humans. So there's a logic train here that says it would probably behoove you to have your robot take some type of human form so that it can take advantage of all of the things that were there. So in the DRC, for instance, they required that the robot be able to drive a
little buggy.
Yeah, exactly. And that was because the idea, while you could, from a ground up, engineer something that's got wheels, can go kilometers downrange, and then get out of itself, I guess, or however it was interfacing to the buggy and go do its thing. But chances are you're going to show up on site, you're going to have your robot, and then you're going to have all of this equipment that was already there. And so the real challenge was, how do you use these things that are already there and already
designed for people?
Well, and may be uniquely designed for that site. You got to remember, this is also after Fukushima and some of the other disasters in which we knew, like the idea that you have a robot that is prepared for nuclear, radiological, biological, chemical, and that you can do and fire. If you can do that full gamut with one piece of equipment that has everything that's needed, that's a hell of an engineering task.
Oh, for sure. But to me, that seems harder than saying, like, okay, we can design a robot specifically for nuclear and a robot. You know what I mean?
Yep. Or take the middle point there, and that's to say, we're going to design something that would be human-like in its ability to use all of the equipment that's already been specifically engineered for that environment. So all of the mitigation strategies that you would have, let's say, for nuclear or radiological, those are really bespoke and really freaking expensive things. So why not just design a robot that, in fact, may fail under those environments over longer periods of time because of radioactive effects and stuff like that, but you don't care, right? Let the robot degrade, let it fail in place, but its ability to use the tools and the equipment that's on site, that becomes super valuable.
So you then made your return to NASA AMES to take the role of Robotics Group Lead for IRG, the Intelligent Robotics Group. Would you be able to speak to your role here, and then I suppose what you loved about working at NASA AMES the most as well? Yeah,
I mean, I'll do the last part of the question first, and that's to say the reason why you work at NASA is for the mission.
Yeah.
So of all of the jobs I've ever had in my career, figuring out how to help mankind do its thing in space, that's cool. I mean, that's the kind of stuff that'll get you up in the morning and make you want to run in and go do cool stuff. Yeah. My job there, though, was more as the group lead. It was less engineering and more people wrangling. So I'd say that in terms of a lot of my leadership learnings and other things like that, I probably learned more during my tenure as the group lead at NASA.
Does that mean you were probably still more technical at DARPA than you were at NASA AMES then?
DARPA is different. So I guess to maybe compare and contrast there, with DARPA, you're trying to change the direction of a technical field. So it is technical in that you have to have a deep understanding or very quickly be able to develop a deep understanding of the thing that you're doing. But DARPA itself, like there are no labs or soldering irons or anything inside of the walls of DARPA. Your job, and you are chartered to change. One of the mantras that they use is, you don't need to solve the problem, you need to change the way in which the field is talking about the problem.
Yeah, you just set the direction of the research.
Yep, and so that was the role at DARPA. So while it was technical, it was not about coding or creating hardware or anything else like that. Yeah. You were inspiring large groups of people to do that. At NASA, though, While during my first tenure at NASA, that was very technical, and that was us actually flying hardware that I had a hand in helping to build and create. After doing DARPA, then going back to NASA, during that second round, it was much more group management, group leadership, and other things like that. So we, for all of the, at any given point, we were running a dozen different projects out of that group. And so it was, how do you manage the people? How do you resource those projects? How do you make sure that in terms of, time, budget, schedule, and all the rest of that stuff, that you're flying and kind of steering that ship correctly? That ended up, the kind of joke that I had coming out of that was I spent most of my career trying to figure out how to be a roboticist. And what I really feel like I should have done was gone and got a psychology degree, because it ended up just more me handling and managing humans than I did with robotics.
I feel like you've probably everyone could benefit from a psychology degree if you've got the time.
Sure.
What was the most exciting project that you feel was going on whilst you were there, or that you were part of?
At NASA, I got to see the full chain. We went from upgrading a piece of equipment called Spheres that was already up on station.
The ISS?
Yeah, yep. I'm sorry, on the International Space Station. MIT had flown back in the 2000s. MIT had flown some really cool hardware that they're basically free-flying robots. So these are things, they look like very colorful little balls, for lack of a better description. They're kind of hexagons in shape.
It's like Astrobee kind of.
So this is the predecessor to Astrobee, okay. And that's what I'd say the most rewarding thing was. I got to watch the full chain of events from I was on the ground floor of us figuring out how to upgrade Spheres to do some of the existence proofs that we needed to determine that an Astrobee-like thing made sense. And
sorry if I ruined your punchline for
no.
that story.
Not at all. And so we flew, like in that case, we flew the first smartphone that ever went to space. And we used that smartphone to interface to the Sphere, and that's how we were doing all of our compute and kind of the command and control aspect of it.
Yeah, awesome.
Then after we flew that then allowed us to make a very convincing argument to NASA headquarters, basically saying we actually believe that free flyers could have almost like a first-class citizenship on the International Space Station, helping astronauts, because the idea that it's there as a flying personal assistant to the astronaut is the first use case. And then the second, there's actually three use cases. The second use case is the ability for the astronaut to use the Astrobee in a remote operations kind of mode. So they are in one module and they are using the Astrobee to do something in another module. And then the final one, and it ended up being the one I think that NASA was most interested in by the time we were done, was the idea that ground controllers, so folks in mission control or even outside of mission control, would be able to kind of check out a Astrobee and to go fly. Strangely enough, one of the toughest things that the International Space Station deals with operationally is positioning and getting cameras where you need it so you can see the thing you need to look at. And so even just the idea of this being a free-flying camera that can go around, that was kind of our MVP, one of our MVPs that we were working. And I'll just say it was actually pretty wonderful to be there, and especially be working as the group lead when Astrobee actually was able to fly, and to watch those successes and to kind of be in the command center when all of those things happened, and you're watching the astronauts celebrating the thing that you've spent the last 5 years of your life building.
What year did they send it up? I remember I spoke to someone from the Astrobee team at a conference once. I can't remember, but do you remember what year they first sent Astrobee up?
Oh.
Sorry to put you on the spot.
Yeah, no, probably, I'm going to guess, and it's probably 2015, 2016.
Yeah, it wasn't that long ago, was it? Yeah,
I was fresh back from DARPA when that hardware was kind of in final assembly. And so it was around that time frame.
Well, just over 2 years ago now, you made your way to almost as far away that you can go, to Perth, Australia. To take over the robotics team here. 2 questions. What made you decide to take the move? And the second is, and what do you hope to achieve in your time here?
So I'd say the biggest reason for the move was realizing that so with NASA focusing on getting mankind back on the moon, and figuring out how we can use robots and other things to achieve that. Basically, Jason Crusane, who was a good friend of mine, who actually came here before I did, so he was here for about a year before I came.
Next interview on Saltology, potentially.
Okay, he's a good one.
Yeah.
He kind of had the epiphany, and it was an epiphany that I then, after thinking about it, shared was NASA. Let's just say NASA, while externally it is amazing, and the mission is just something that you can absolutely gobble up. That I'll just say, working for the U.S. government under the Trump administration was a little more difficult than I certainly was having an easy time bearing. But then also, on top of all of that, I think there was this epiphany that that we're frankly destroying the planet faster than we might be able to get off of it. So if our ability to work on other planets, or to be kind of a species that can survive off of this fragile little planet that we're on, that if you look at it and measure your career in maximizing the impact that you can make to society or to the world or whatever. Jason had the epiphany, and then I later shared the epiphany, that I could do more good for humanity by figuring out how to capture and us be able to use new energy and carbon capture and other things like that. And so I very much, with Woodside being so forward-leaning in terms of its want to do new energy and other things like that, it occurred to me that I could frankly have more impact trying to achieve that. And I guess the part that I was okay with was I knew that there was this amazing team that I had the pleasure of supporting as the group lead for the years that I was there. Yeah. I knew that I could step aside and this amazing space robotics thing would continue.
Yeah.
And so that was the flip over to the oil and gas side. The running joke is that we're trying to figure out how to make robots work in oil and gas such that when new energy is ready for us, then it's just a matter of switching the domain. Right now, oil and gas is paying the bills. Yeah. And with all of the initiatives that Woodside has in terms of its clean energy or whatever, I feel confident that we're going to get to a place in which robots are really contributing to the new energy side.
It's the dream.
That's the hope.
So we just signed another Space Act agreement between Woodside and NASA. What do you hope to achieve with this second round of collaboration?
So the new Space Act agreement is real specific in that it's going to explore humanoid robots. So it's a little bit of it kind of in the DRC, DARPA Robotics Challenge kind of vein. I'll just say, after now being in experiencing oil and gas and the kinds of work that we do and the kinds of environments that we're working in, I did not used to be someone who supported that the robot needs to be in a human form. I actually used to be on the other side of the coin, as evidenced by like Astrobee. Astrobee actually was flying in the face of
just the head.
Well, Robonaut, exactly. Well,
forget
precisely.
The body.
Yeah. So there was definitely initiatives at NASA that were doing the same thing, where it was like astronauts have human-shaped tools, tools that are shaped for humans to use, and so robots should have that. And we were on the other side of that engineering coin, that was to say, well, no, actually, you should optimize the shape of your robot for the application. Don't be constrained to what evolution has provided us in terms of bodily form. We can go someplace else with this. And so I'm on the other side of the coin now, and that's to say our ability to work with NASA plays well into the ability for these robots to, like, let's say, be on our offshore assets and other things like that. So that's the NASA arrangement. We're going to be hopefully getting working on Valkyrie.
Yeah, pretty awesome.
Which is, and that robot, its premiere was the DARPA Robotics Challenge also.
Yeah.
And so for me, it's a bit of a homecoming, in that a lot of a robot and what will hopefully be maybe future versions of robots like that are ones that have kind of been in my life for a while. And I'm excited to get Woodside involved in and starting to scratch the itch that is the idea that we have a humanoid robot that is like on one of our offshore assets, working in a environment that was designed for humans. That actually seems really natural for us to go down that route.
That'll be pretty epic.
Yeah.
Let me know when that POC is happening. your whole life you've worked on robotics where the cost of failure is high stakes. So whether that's search and rescue or in space, in the fire department, or now on oil and gas processing plants where you have, lots of potential ignition sources and that could make huge explosions. What advancement or advancements in the robotics field do you think will create the next big step change for these capabilities? So something that hasn't sort of happened yet, or is maybe on the periphery. Like, what do you think it will take, like, for robotics in those fields to sort of take that next leap?
I'm going to answer the question probably not the way you want. I actually don't know, at least in my experience, that leaps are the way that solutions like that are created.
Mm-hmm.
I actually think it's really slow, almost painful, just diligence.
Mm-hmm.
As I look, like now we have robots today that do, especially like in industrial inspection and other things like that in EX-rated environments, which is to say environments in which things may explode. It took decades before we were able to inch forward in terms of those kinds of technologies.
Yeah.
NASA's another one, although it is pretty freaking grandiose when the rocket launches off the pad and the thing goes to station and the robot does whatever it's going to do. The path of getting to that success, everybody remembers that, like, crashing through the finish line and it all being awesome. What they don't usually see is the half decade prior
For sure.
of just slow and gradual grinding to get yourself there. So
well, I guess understanding it won't be an instantaneous leap, but if there's like a problem that you could look at and be like, you know what, once that's solved, like, I think things will take off. You know what I mean? Like, is there? I'm going to try and corner you into that.
Yeah, no, it's a good question, and frankly, so the real trick here is if you know the answer to this question,
then
you should probably just go get it done.
Go.
I mean, I know. So one of the largest barriers that I see, and it's been a theme throughout my career, and it was a theme that we were definitely trying to figure out, like with the fast lightweight autonomy program that I was talking about before.
Mm-hmm. The drones.
I'll say as a roboticist and as somebody who's like has worked on making robots do things, you always feel like you're starved for information or starved for a representation of the world that allows you to do decision making or allows the system to adaptively decide what it's going to go do next.
Which is like huge in the machine learning space right now in terms of like being able to go from image feeds and actually create like a latent variable space that you can is easy to create actions from.
Yep. And so what does that knowledge representation look like? What are the sensors that are feeding that?
Yeah.
If you're leveraging neural nets or machine learning or whatever, what does the back end of the learning process look like?
It's something we do really well, as in humans do really well,
Because we had to learn to adapt. Well, so we've had millions of years worth of evolution that has allowed us to converge on what for us ends up being a pretty decent existence in which we have to be smart, we have to sense things, we have to keep the tigers from eating us in the plains of Africa. And we managed to do all of those things fairly well. Yeah. I would argue that, like, right now for robotics, we're still not very good at having a robot survive, like in that case being eaten. Like the evolution and the if it dies it doesn't get to procreate, that ends up being a really great focusing or limiting function in terms of what the positive outcomes are that you're seeking. With robotics, we don't have that. We don't have the privilege of just eating every robot that doesn't do what we want it to do.
No.
Now that's where machine learning and neural nets and everything else try to leverage on the software side. To me, what's kind of interesting, though, is like I still feel like the systems that we're building are still starved for the really rich information that we get through our eyes and through our smells and through all of the senses that we have as humans. The roboticist in me still wants to like shake my fist at the cloud and go, we need better sensors. I now, with too much gray in my beard, realize that that's not the answer.
Yeah.
But I think that our ability to not only have really great sensors and then really great ways of capturing that into a like knowledge representation that allows us to process that thing intelligently and adaptively, that would be the next big step. If we could just achieve that in one swoop, that would actually be a really, really great improvement to the systems we're building.
Well, I remember there was I think it was at Europe's a few years ago, it was Peter Abiel, who's the one of the best in the world at robot learning. he basically proclaimed to the whole research community that the robotics hardware has been good enough for a while now.
Yep.
A limiting factor is software, and in particular, as we were talking about, knowledge representation.
Yep. I think the pendulum swings.
Mm.
I would say, like, right now, for those researchers that, let's say, 10 years ago were struggling to have a bipedal robot walk across the room, the hardware and the software that's the control software for that is caught up. Now, what hasn't caught up is, okay, that robot just walked across the room. What's it deciding to do next?
Yeah.
That the higher level goal and the kind of the deliberativeness in which humans walk around the world and find things to go or do and solve, that's the part that we don't have in robotics right now. So even in the last decade, we're dramatically further than I think those previous robotics folks would have imagined that we would actually just have it commercially available. Yeah. The idea that you commercially can just go buy a spot is mind-blowing.
It's pretty cool.
To roboticists like me that grew up in the late 90s, early 2000s, in which it was a wheeled platform that looked like a garbage can and pretty much had 3 wheels. Yeah. And we were lucky if it could get across the lab and not, strike anybody or a piece of furniture.
Yeah. It was pretty, I think when the first time I flew over there, just to walk into the room and see just like 100 of them just in a line, in a production line, was pretty epic. So we're kind of moving into the fun questions now.
Okay.
So actually maybe this one's not that fun, but the next one's a fun, I promise. As someone who did a PhD and sort of worked extensively in research, but then has also sort of worked as a project manager and a group lead, how do you find the balance between building your leadership skills whilst also staying sharp and up to date technically?
I'll just say I aggressively fight to keep that technical edge sharp.
In your hobbies, in your spare time, yeah.
So that's it earlier where I joked about on any given Saturday.
Wasn't a joke.
I'm geeking hard, yeah.
Yeah.
That it's now what's interesting maybe is that I have to separate my work. Like I sometimes do, but for the most part I am not doing robotics on the weekends.
But it's still adjacent sort of fields.
Yeah. So it's for me the sword that I'm trying to sharpen in terms of my technical skills like today is more on the security, what now we term cybersecurity or info security type things, and that's where my interests are drawing me to go and I do study hard in terms of trying to make sure that I can get very deep into that technical area, and because that actually it brings me joy to learn those new things.
I think that's so important, hey, in terms of forcing yourself to learn something you're not interested in.
Yep.
Versus if you actually, if that's what's drawing you at the moment, then don't fight it. Just go for it.
Well, it's there's a mantra that I've always had, and that's just if there's anything that's led me to anything that might be confused with at least successes or otherwise in terms of my career, it's that my dad used to always say, just chase your smile.
Chase your smile.
And so after having a couple of positively reinforcing moments in my life in which I was able to bootstrap that behavior pattern, that's a lot of that I would say that would be a general theme. So, yeah.
If you could talk to a younger version of yourself starting your career today, what would you tell yourself? This is where it gets fun.
Yeah, no, I would name a couple of ex-girlfriends that I would say, don't just walk away from that. That's going to be really distracting for you from a career progression standpoint.
Not worth it.
Not worth it. Or worth it, but just understand the baggage you're going to carry from that point forward.
Yeah.
So a lot of us, I guess the biggest thing, and it was certainly for me, and it's something that I see in a lot of the folks that I try to mentor and that I see working in our labs and in the different spheres that I work in, and that's that a lot of my energy, I remember there being just a lot of anxiety with regards to what do I do next.
Yeah, and that's always, right?
Yep.
I feel like I have that.
But I wish I could go back and if I could take the experience that I have now and what, at least right now, I don't worry. I have a lot less anxiety with regards to what I'm going to go do next.
Yeah.
And again, I've had some wonderful and fortunate positive reinforcement data points that have allowed me to kind of hit this place. But that's to say, You're not going to have, like, I wish I could go back and tell myself, you're not going to have a problem finding employment if you keep with the passion and the drive and the interest that you have in the things that you're doing now. Stop worrying about whether you're going to be able to pay rent or have food.
Yeah.
And truth be told, there were moments in which that was actually a pretty decent concern, especially when we were doing the startup.
Yeah.
It was like, I literally don't have a paycheck this month and I have no sales in the pipeline and I might not be able to have a roof over my head next month. The trick there is there's a little bit of luck, but there's just a lot of being prepared into keeping yourself moving forward. I wish I could go back in time and just instill a little bit more of that in me.
Yeah. It's going to be fine.
It's going to be fine, and even when it's really, really, really bad, you're going to work yourself out of that. Now, that's not now. What I wouldn't go back in time is go back and say, don't worry about it. It'll be easy. Like, you're going to work your ass off. Mm-hmm. But the idea that you're going to die cold and alone, and in a horrible place.
Worry about the right things. Don't worry about them. Just worry about chasing that passion. Don't worry about
the things that you can control, and really your passions, what you're like wanting to do in life, and frankly, the things that bring you joy. Again, and it has been a fortunate walk. It's like I've found that if I concentrate on those things, that'll almost always lead me to the right place.
If you could think back to sort of one pivotal moment in your life, or a turning point, or a key decision that you made that impacted your life the most, hopefully positively, is there one that comes to mind?
It's kind of a series. It's funny though, as you said that though, the one, and I think it was maybe an epiphany of perspective is what the professor was giving me. When I was doing my master's, on the World Trade Center, there was a lot of kind of decision making and other things that I needed to work out, and that experience wasn't ending up where I needed it to be in terms of concluding that work such that I could go forth and do other things. Mm-hmm. And that professor kind of sat me down and he said, Mark, he's like, look on the inside of the cover page. This thesis, it says, for the partial fulfillment of the degree requirements. That's it. This is not your life's work.
Yeah.
And at that point in my career, I remember almost being like, almost adamantly disagreeable with him to say, no, this is my life's work.
Yeah.
Like, this is what I'm here to do.
This is everything.
I'm literally saving people in rubble piles. How dare you say that this is not my life's work? What he was giving me was a glimpse of perspective, and that even if you can have something be what at that moment you believe is your life's work, but he was right, in that I would then later go on to do a startup and to go to NASA. NASA has very little to do with what I was doing for the other thing there with the World Trade Center stuff or whatever. And so it is, I would say that's probably what I think I earned maybe there in terms of his bestowing upon me that knowledge, was just the idea that at any given moment, no matter how good or bad or otherwise you are doing in your career, that's just that moment of time.
Yeah.
And what you're doing and the thing that you're stressing out about is probably just a partial fulfillment of whatever it is that you're actually going to do in your career.
Yeah.
It's
just one chapter of the of the total book.
And what's amazing for me is that he said that almost like he was trying to be hopeful, but he said that with a wisdom that I knew he had earned that understanding
but
himself.
You hadn't,
and I hadn't. And so now I can look back, and what's interesting is that professor is now, I don't think we've actually spoken much since. But I
could send him a message, say you're right.
Seriously, and I should. It's funny how you have those people pass through your orbit, provide you with a wonderful gravitation field that changes your direction, and then you get to benefit from that.
What would be the thing that excites you most about the future of technology and humanity, and you can go as far forward and as crazy as you want to, as in you could say, like, self-driving cars in the next 5 years, or you know what I mean, or whatever it might be, when we put a colony on Mars. Like, what is it about the relationship technology and humanity in the future that would get you most riled up?
This will sound like I'm being hyperbolic when I say it, but I actually truly believe that technology is the only way we're going to get ourselves out of the crisis that we have right now.
Mm-hmm.
It's weird to say I'm excited about solving the fact that we're about to destroy the rock we live on. But I actually think that it will be when we get on the other side of solving those problems, and I do believe we're going to solve those problems with technology. I don't believe it lies in policy. I don't believe it lies in like the idea that we globalize the way that we let's say the Western worlds live today. If that globalizes, then we destroy this entire planet. The only thing I think that breaks a lot of those cycles is our ability to leverage technology to lessen those effects. And so whether that be autonomous cars or robots or carbon capture or finding ways of doing more efficient hydrogen production, like all of that to me is lumped into the same technology advancement for us as a species, and that's what I'm excited about. Otherwise the alternative is pretty freaking dystopian, and I'd really, at least in my little humble opinion, I think it's technology that actually saves us from that.
Is it like a specific piece of tech that once that arrives and is fully functional that you think that's pretty cool?
With a lot of, and of course, we're doing a lot of this work here. If we are able to sequester carbon, that's huge. That actually takes so much weight. At that point, we can actually use heavy fuels, fossil fuels, hydrogen, wind, whatever, and it doesn't actually matter because we're able to remove the carbon, which is one of the biggest catalysts for us having issues now. So if that existed, I mean, that's huge. That is such an enabler on so many different levels.
Yeah.
That the effects of that, I don't know that you could even really measure them well. That would just be a game changer for us.
If you could assemble the best, most skilled and talented team in the world, resources weren't an issue.
Yeah.
What problem would you solve?
I would. So, and this is going to sound like a loaded answer, but I would actually go after new energy and carbon capture, which is exactly what we're doing here. What I'm eager to do is to get us a little bit further ahead in that exploration so that we actually know, so a lot of the work that we're doing right now is very, and from an R&D sense, it's still like somewhere between R&D. We know the kinds of things that we need to build to help with energy and to help, basically with carbon capture and other things like that. We don't necessarily know how to scale it. The idea that as we start, the needle starts moving much, much more toward the D, which is to say, okay, we know what to do and now we just need to do it at scale. I would love to assemble that team and literally figure out how to save the planet and to save our ability to have energy in it. So.
If you could take a one-way trip to Mars, would you do it?
For sure.
And what would you tell Faith?
She would. She's been surprisingly supportive of all of my crazy adventures. And so while I'm sure we would have the teary-eyed, Armageddon moment where, where it's, I need to get on the rocket, babe.
Yeah. But you'd do it.
Yeah, for sure.
For sure. If you had to have done something other than robotics, what would you have done?
Either I would have stayed in IT. I had lots of friends that stayed the course on IT, and I'll admit I'm a little jealous of them now.
Okay.
And that's to say, by no contribution I made to the field, it became a proper field. Like you can now, and in fact, cybersecurity experts are some of the best paid professionals on the planet.
Yeah.
And what's funny is a lot of the problems. I'm not going to say this as if we knew all the answers, but there was many of us that could see the world that we now live in terms of there being monetization strategies that make cyber criminals very aggressive in their techniques and the idea of nation state level hacking efforts and other stuff like that. There was a lot of us that were seeing that back in the 90s and early 2000s. I tapped out because I was burned out. And so it's one of those where there's a whole cohort of my friends that have stayed in that.
Yeah.
And I can now say with a little bit of a grin on my face, being now, fully entrenched in robotics or whatever, I think I would have been pretty good if I would have stayed that career path. The other career path that I probably there's a parallel universe in which Mark is just driving an 18-wheeler, just a truck,
Yeah.
across probably the U.S. And that's one of those things where I don't have any problem just kind of sitting in my own head and working out problems and other things. And I've always loved, especially open road driving.
Yeah.
And so it's weird to say, I either would be wanting to sit on the bleeding edge of cyber
Or just driving a
response, or just sitting behind the wheel of an 18-wheeler. So
it's funny because the path you picked is probably going to be the field that makes driving the truck on the long road redundant, right? So
that's right. It's my evil plan.
Yeah.
If I can't be a trucker, nobody will.
Yeah. If you were to retire today, or let's say tomorrow, what aspect of your career would you be most proud of?
It's funny. I think because the space stuff was so ingrained in my childhood. So growing up in South Florida, where I can remember like literally being single-digit years old, and us going out onto the roof of the school to watch the shuttle launch.
Yeah. Awesome.
And in South Florida, you can do that. And in that at the time, working for or being just in the orbit of NASA just seems so just an impossible.
It's a mystique.
Like you just who is able to do that. And so I'm proud of the ability to have gone and done that. But again, just the accidental nature of like my ability to have contributed at the World Trade Center and to have contributed in multiple disasters in which we were trying to inch forward on robots being able to contribute to search and rescue or whatever.
Yeah.
That was so strangely enough, I consider that more of an uphill battle and more of a struggle than what it took for me to work in and to be successful at NASA. It's hard when you're trying to make markets that don't exist in a market that doesn't necessarily want what you're building.
Yeah.
That's a little different from NASA, which was desperately trying to find technology to allow us to succeed in the things that we were doing. It's a different mode of operation.
Yeah.
So,
if you could interview anyone in the same way that I just interviewed you, who would it be?
Oh, that's a good question. Probably, so one of my mentors, and he was the original program manager, and he's somebody that I know very, very well, but I find that every time I sit down and have a beer with him or whatever, I find some other story that I had no idea even existed.
Yeah.
His name's John Blitch. I realize I should be answering like Gandhi or
No.
Elon Musk or
No.
Somebody who would show up on Joe Rogan next week or whatever. And in fact, I would love to, and maybe have the opportunity to do an interview like this with some of my mentors, because at least in two cases of really, really great mentors I've had, what I found with both of them is, for whatever depth it is you think you know about that person, there's more down below it, and what I find is that the deeper you go, sometimes the more profound the lessons are, and the better the capture.
Might see him on Micirology.
I will aspire to these heights.
Absolute last question. If you could only recommend one book to someone for the rest of your life, what would it be?
One book. I can tell my favorite.
Could be a favorite, but I'm just like, if you could only recommend that, to one you can recommend that one book to people.
Oh, I should have a better answer for this than I think I'm about to do.
You can take your time.
So one of my favorites it's a book called The Art of Racing in the Rain.
Okay.
Don't watch the movie. It's horrible.
Right.
But the book is the world from the perspective of a golden retriever.
Okay.
And of course it's also based around he is the pet dog of a race car driver who's going through a whole bunch of turmoil in his life and other things like that. And seeing the world through the eyes of a dog. The author does an amazing job of taking you along for that journey.
Yeah.
I've joked, how they have different personality types, and you're able to like attach personality types to dog types or whatever.
They actually did that.
No, they haven't, but in every one I've ever done, I've always come out as the golden retriever.
Yeah.
So it's not by accident that I think for me that book resonated with me so strongly.
Yeah.
It's not a complex book, and I don't know that it's one
that you'd recommend.
Well, I don't know that it's one that you walk out of the end of that book going, wow, I have accumulated the following 3 life lessons that will really lead me well.
Yeah.
But it's one that I would say so the 2 that I pick up the most often, I've reread Art of Racing in the Rain, God, probably 4 or 5 times.
Okay.
The other one is Snow Crash by Neil Stephenson.
Don't know.
Okay. So Snow Crash is now where it's relevant today is the term metaverse. Comes from Snow Crash.
Okay.
And while I will admit, so Neil Stephenson is an interesting science fiction author. At that stage in his career, he was notorious for not finishing books well. The books would kind of run off a cliff. But Snow Crash, I will if I have an evening in which I just want to be inspired, I will pick up Snow Crash and read the first 2 chapters, and it is like this obnoxious, over-the-top Michael Bay style trailer of what the future might look like.
Awesome.
And it is riveting. So
okay.
So those would be my 2.
Mark, thank you so much.
Yeah, man.
It's been good.
Been my pleasure.
And I'll be sending you the finished product soon.
Cool. Looking forward to it.
Thank you.